All right, next up for us is to work with our z-scores the other direction. What we've covered so far is that we have a raw score and we want to turn it into a z-score. If it's super simple stuff, we can sketch an answer to it, but if the numbers get a little messy, then we saw the formula and what to do. Now what we're going to do is go back the other direction. Now we're going to take our z-scores and turn them back into raw scores. We'll see later on in this chapter why we would probably want to do that. It's connected to our second purpose. But in any event, so I already have up here for us a distribution with a mean of 50 and a standard deviation of 12. So I've counted up and down by 12s. And we have a z-score of 2, positive 2. So where is that? That's exactly 2 standard deviations above the mean. 1, 2. Well, we really don't need any new formula for this. It's like where we started the last time. In this case, it's pretty straightforward. It's the new raw score is at 74. Let's say within this distribution, someone else has a z-score equivalent of -1. Well, what raw score was that? Well, we go exactly 1 standard deviation below the mean. And we can see the answer there is 38. Let's do another one. Let's say we have a z-score equivalent of positive 0.50. So a half of a standard deviation. So we know it's above and we know it's halfway. We know that's there. Well, if a whole standard deviation now is worth 12 points, what's a half of a standard deviation? Well, half of 12 is 6. So it's going to be a half a standard deviation above the mean. The mean is 50, and we're going 6 points above that. So we know the answer there is going to be 56. Oops. Right, let's do one more. Let's say we have a z of -1.5. Well, same thing. We're going to go 1.5 below the mean. So going down by 1 whole standard deviation means we're going down by 12. So we're going down to 38. And then we're going down 6 more points, another half of a standard deviation. So 38 down 6 more is 32. Again, we're going to see that there's a formula for this as well, that sometimes it doesn't all work out with nice even whole numbers. But in this case, again, we're dealing kind of more with on the concept level of it. So we can turn our raw scores into z's, our z-scores back into raw scores. Let's take a look at, let me go ahead and get rid of this curve. Let's take a look at the formula for it. It actually is the exact same formula as the z-score formula. But we're not solving for z in these cases, we're solving for x. So all that's happened here is that the formula has been rewritten so that it solves for x instead of solving for z. It's as simple as that. So you could really do it all with one formula. What I find is for almost any kind of problem I'm working on, if I'm looking for a z-score, I use the z-score formula. If I'm looking for anything else, I use the raw score version of the formula. It's just a little cleaner and easier to work with. So what does that look like? If we have a raw score, how do we solve for that? So again, if we want to turn our z's back into raw scores, well, that equals the population mean plus your z-score times the standard deviation. Again, it looks differently, but it is the exact same formula that we already had, just rewritten, algebraically rearranged, so it can solve for the raw score. So let's go ahead and just do the last one here as a computation example, then we'll take it on a little bit further. So here, what we wanted was the raw score. We didn't know it yet. The mean is 50 points. The z was -1.5. And the standard deviation was 12. So -1.5 times 12 is -18. If you are adding a negative number, you are basically just subtracting, right? And we get down to the same answer, 32 and 32. So we looked at that a couple of different ways in that regard. So now we're going to take this forward and look at some other things. We talked about in chapter 3 with a formula for the mean that it really was kind of a 3-part formula, and if you had any 2 of those parts, you could solve for the third one that's missing. Well, this is kind of a 4-piece formula, if you will. There's 4 symbols in this, 4 pieces of it, but the same thing still applies. If we have all the pieces but one, we can solve for that missing piece. And again, you could use either formula. I find personally that that's the far easier one to work with. So let me go ahead and clean the board off here, and we'll take a look at a couple of examples of that in the next clip.